Welcome to Ask and Learn.
Okay, well, this is the problem 36, and in this problem we have a four-stroke engine that operates in an Otto cycle, and we have to find how much power will produce when operated at 2,500 rotations per minute. Okay, so first of all, we must find out what is power. What is the definition of power in an engine? So the power is represented as W dot. So this is power, and it is defined as the mass of the gas operating in this engine times the network produced by the engine times the network per cycle, okay, times the frequency. So times the frequency divided by the number of revolutions. So the number of revolutions. Okay, and what is the frequency of this engine? Well, the frequency, as we already know, is 2,500 rotations per minute, and minute is divided by 60, so this is hertz. And what is the number of revolutions? Well, the number of revolutions is it's something that we know about the type of engine. So since this is a four-stroke engine, that means that this engine makes 2 revolutions per cycle. Okay? So only because this is a four-stroke engine. Okay, well, therefore, the only problem here is to find what is the network per cycle. And we know that the definition of network is just the heat in minus the heat out. And since we are dealing with a problem when we have to work with constant specific heats at room temperature, we can say that this is just Cv uh, T3 minus T2 minus Cv T4 minus T1. Okay, and rearranging this, we have that the network per cycle is just Cv temperature 3 plus temperature 1 minus T2 plus T4 and close parentheses. Okay, well, what is left to us is discover what is the temperatures of this cycle. So the temperature 1 and the temperature 3 we already know because the problem gives us. Therefore, the only problem is to find what is temperature 2 and what is temperature 4. And since we know this is the process for 1 to 2, the process 1, 2 is an isentropic process. We can use the isentropic transformation, which is this one and here. Temperature 1 times V1, V2, K minus 1. And as we know, V1 divided by V2 is just the compression ratio, R, which the problem also gives us. Therefore, the temperature 2 is going to be 565 R. Remember to transform the temperature. Then multiply the compression ratio, which is 10.2 to the power of 1.4 minus 1. Therefore, calculating this, we have a temperature 2 equals 1430.7 R. Doing the same for the temperature 4, which is also an isentropic transformation. with the point 3 of the cycle. So this is T3, V3, V4, K minus 1. And this is the inverse compression ratio. So this is 1 divided by R. Therefore, we have 2860R that multiplies 1 divided by 10.2, 1.4 minus 1. This is 1.4 minus 1. Therefore, this is equal to 1129.4 R. Okay? Well, now that we have the temperatures of this problem, we can finally calculate what is the network. Therefore, the network per cycle is going to be the CV, which is 0.171, that multiplies the temperatures. So this is just 2860 plus 565 minus 14, 30.7 plus 1129.4. All this multiplied by R, and with this we calculate and find that the network per cycle is going to be 147.9 BTU LBM. Okay, so this is the network. Now we still have one problem, which is to discover what is the mass of the gas. And the total mass taken by all the 6 cylinders, because we have a 4-stroke engine with 6 cylinders. Therefore, the total mass, let's call this M, taken by all 6 cylinders is going to be the N of the cycle that multiplies delta V, the average volume, divided by V1, okay? So therefore this is just N of the cycle. The average volume is just pi times B squared that multiplies S divided by 4, because this is a cylinder, divided by V1, and well, this is going to be equal 6 because it's the number of cylinders. Sorry, I call cycle, but it's cylinders. This is the number of cylinders because it doesn't make any sense to be cycle. So the total mass is the number of cylinders, which is going to be 6, that multiplies the average volume of the cylinder divided by the volume 1, okay? So we're going to have a total volume of mass in here. Therefore, this is going to be 6 because it is 6 cylinders that multiplies pi 3.5 divided by 12 because we have to make the conversion that is in inches in here, square, then multiply again, we have to make the conversion, 3.9 divided by 12 divided by 4 divided by the volume 1, which is 1495. Therefore, calculating this, we discover that the total mass taken by all 6 cylinders is 0.008716. Therefore, the final answer, which is the power that we want to calculate, let me see, the power is going to be 0.008716 times 147.9 divided by the number of revolutions, which is 2, that multiplies the frequency, which is 2500 divided by 60. And there is another thing we have to pay attention here in this problem, which is the units. We want the units in horsepower. Therefore, we need to multiply by the transformation of horsepower to BTUs from BTUs to horsepower. So 1 horsepower is 0.7068 BTUs per second. Okay? So multiplying all this, the power of this engine is just 38 HP horsepower. And that's the final answer. Thanks for watching.